Hi, welcome to AVL tree insertion operation. In this example, we are going to discuss about single rotation LL. Here, the list of nodes are given with 50, then 40, then 60, then 30, 45, and 25. So now we have to create the AVL tree, and whenever we are inserting the single node, we should check the balance factor. First, we will create the node with 50. So 50, I am creating the node, then check the balance factor. So left subtree is null, right subtree is also null. So balance factor will be 0 minus 0, 0. Then it is satisfying the balance, I mean AVL tree property. Then we are checking the second node 40. So 40 is less than the 50, then it will be added as a left subtree of the node. Again, you have to check the balance factor of the tree. So balance factor for this one here, left subtree is also height is 0, right subtree height is also 0, so it will balance factor is 0. Now balance factor for the 50 is in the second time, so it is updated. So here left subtree height is 1 minus right subtree height is 0 for the 50. So 1 minus 0, it will be 1. So both are satisfying the AVL tree balance factor. Then we are adding the 60. So 60 is greater than the 50. So it will be added as a right child to the 50. So now again you have to check the balance factor. Here balance factor for the 40 is 0, 60 also, left child is null, right child is null. So height of the both left subtree and right subtree of the 60 is 0. So the balance factor will be 0 minus 0, 0. So here the for 50 balance factor going to be updated with the left subtree height is 1 for the 50, and right subtree height is also 1. So 1 minus 1 equal to 0. So it is satisfying the balance factor. Then we will add the 30. So 30 is less than the 50, so it is going to the left child left subtree. Already 40 is available as a left child to the 50, so we have to go check with the 40. So 30 is less than the 40, so it is going as a left side. So here there is no child left child for the 40, so we can add that 30 as a left child to the 40. Again you check the balance factor. Now when you are checking the balance factor, so for 30 it is a leaf node, so no left subtree and right subtree, so height is 0, 0 minus 0, balance factor is 0. For the 40 you have to update that. So left subtree height is 1, right subtree height is 0 for the 40, so it will be 1. Then for the 50 also balance factor will be updated. Left subtree height is here 2, right subtree height is 1, so it will be 1. Then for 60 it is not updated because both left subtree height and right subtree height for the 60 is 0 minus 0, so 0. So then we are adding the 45. So 45 again checking with the 50, which is less than the 45 is less than the 50, which is going as a left subtree. So in the left subtree again we will check the left side. So yes, already 40 is there, so we will check 45 with 40, which is greater than 45 is greater than 40. So the it will go to the right subtree for the 40. There is no child in the right subtree, so we can add that 45 as a right subtree to the 40. Now you check the balance factor. So here balance factor for the 45 is 0 because no left child and right child. Then for balance factor for the 40 will update now. Here left subtree height is also 1, right subtree height is also 1 for the 40, so balance factor is 0. Then for 60 it is not updated, and 50 also we have to check because newly added the node. So here again the left subtree height is only 2, only 2. Then right subtree height is 1, so it is 1. So again still it is satisfying the AVL tree property. After this I am going to add the new node 25, new node 25, this one. So now when you are adding the 25, here you check with the 50. 25 is less than the 50, it will add it in the left side. 25 is less than the 40 you will add it in the left subtree. Then there is already node available in the left subtree, so 30. So you will compare with the 30. Still 25 is less than the 30, so you check that. So 30 is not having the left child now, so 25 will be added as a left child, so it will be a null. So here also null. Then for 60 also both children are null. So now you apply the balance factor calculation. So here height of the left subtree and height of the right subtree for the 25 is 0 minus 0 0. Here for 45 also there is no right subtree, 0 minus 0 equal to 0. Then here also no right subtree and no left subtree, 0 minus 0 0. Then here for balance factor 30, so height of the left subtree is 1, height of the right subtree is 0 0. So 1 minus 0 is 1, it is satisfying the balance factor. 40, here height of the left subtree is 2, 2 minus height of the right subtree is 1 edge, so 1, 2 minus 1 1. Then height of the left subtree of the 50 is here two paths available. One path is this one, so 2. Then one path is this one, so 3 edges, 3 edges. So maximum of 2 comma 3 among the maximum of 2 comma 3. So 3 is the maximum value, so 3 is height of the left subtree of 50. Then right subtree height is here only one edge available, so 1. So 3 minus 1 2. So now which is not satisfying the balance factor of AVL. So we have to check when it is not satisfying. When we have added the 25 in the left subtree of the root as a left child, then the balance factor of the this node is not satisfied. So we have to perform LL rotation. We have added the left subtree and as a left child, right? So we have to perform the LL rotation. LL rotation means we have to perform clockwise rotation of this top node, the balance factor which is not satisfying the node. So now we have, when you are rotating, this 50 will become child to the child to the 40, child to the 40. Then its right child already 60 available, but 40 is having already right child as a 45, right child as a 45. So this 45 is right child. Now this is going to add as the left child of its previous parent. 40's previous parent is 50, 50 is the previous parent of 40. So for its previous parent, the right child of the 40 is going to add as a left child. So now you look at that, this is the structure we got after rotation. Now we will check the balance factor for this. Left subtree height minus right subtree height 0. Here left subtree height is 1, right subtree height is 0, so 1 minus 0, the balance factor is 1. For relief node 45 also 0, 60 also 0. For 50, left subtree height is 1, right subtree height is 1, so 1 minus 1 you will get 0. Then for 40, left subtree height is 2 minus right subtree height, two paths available. This is one path and this is one more path. So 2 comma 2, maximum of 2 comma 2 2, so 2 minus 2 0. So now it is satisfying the AVL tree balance factor property. Then this tree is called AVL tree. So this is the way to perform the LL rotation to make the balanced tree. Thank you.